Question 8a, integral between 2 and 3 of 2 over 3x. So, bringing the 2/3 outside the integral, 1 over x dx. And this is a standard integral. The integral of 1 over x is log x. So we get that the integral equals 2/3 log x between 2 and 3, which we can work out. So this becomes 2/3, putting the first limit in first. So this is log 3 minus log 2. And work that out, and you should get the answer that's on the paper. The next step is to sketch the curve. So if we look at the original function, y equals 2 over 3x, then sketching the function, thinking of it as 2 over 3 times 1 over x, then as x gets bigger, then 1 over x is going to get smaller and smaller. So as x gets bigger, y approaches 0. So as x gets bigger, y approaches 0. So it's going to do this. But as x gets smaller, 1 over x gets bigger, especially when x is less than 1. And so in the limit where x equals 0, we have this special case where 1 over 0 is actually infinity. So as we approach the origin coming from the right, y gets bigger and bigger and bigger and actually approaches infinity here. As soon as we go negative, again, a negative, very, very small number gives a number approaching infinity. So this comes up from infinity and effectively does this. So this curve does this. And if we look at autograph, we can see that confirmed. We sketch it out like this. In this question, though, for this model, we are looking at only the area of the curve between 2 and 3. So if I look at autograph on here, I'm going just between 2 and 3. And so we can see that so long as we stick to these limits here, between 2 and 3, there's no problem using this model. However, you can see, looking at it, that if our limits are around about the 0 point, then we've got to be careful because the function approaches infinity at 0. So for this particular question, there isn't a problem so long as we stick to the limits that we have here. Between 2 and 3 is not a problem. And you can end it with a value, as you've done.